Hello, we are the IMPULS team from the Faculty of Mechatronics and Mechanical Engineering at the Kielce University of Technology. And here is our IMPULS Mars rover. There are 16 of us in the IMPULS team. We work in 5 sub-teams, each responsible for a different aspect of the current project. The entire work is supervised by Kamil Borycki, the team leader, who is responsible for the organization of work and duties. Kamil is also in charge of the programming sub-team. The other sub-team leaders are Laura Staniszewska, taking care of science and geology, Szczepan Kostecki, involved in electronics and communication, Jakub Lesiak, in charge of the documentation, and Daniel Włodarczyk, responsible for design and mechanics. Our team has been engaged in designing and constructing Mars rovers for various international competitions since 2014. Our achievements include winning the European Rover Challenge 3 times in a row in 2018, 2019 and 2021, and winning the 2019 University Rover Challenge in Utah. We believe that participation in the European Rover Challenge is a perfect way to develop our skills and learn new things in different areas of science and technology. This event is an opportunity to broaden our horizons and exchange experience internationally. It is a chance to meet and build cooperation with other teams, as well as scientists and businessmen from the space and robotics sectors. Our rover is equipped with an emergency stop system. The most important element is the easy-to-spot red button. Once pressed, it initiates an immediate shutdown of all the DC motors and a standstill of the electronics and navigation systems. The robot can be reactivated by releasing the safety button. Safety buttons are located directly on the rover and in the control case. Moreover, there is a speed limit force for the rover's wheels and additional ones regarding autonomous navigation and driving in a tilted position. Our rover is controlled with communication system operating in 3 frequency bands. In the current project we use industrial radio modems and analog and digital cameras. The control panel includes wireless radio transmitters to communicate with the rover and a specially designed control box equipped with a laptop, 2 LCD monitors, joysticks and switches to control it. The rover is designed to traverse challenging terrain, including loose rocks, boulders and soft sand. With a flexible, independent suspension and a low center of gravity, it can cope with slopes tilting up to 60 degrees. The 6 degree of freedom manipulator, with high-performance train wave gears and PID controllers, is able to perform precision handling operations, for example precision placement. The inverse kinematics algorithms used for the manipulator control help automate the steps in the maintenance and probing task. Manipulator's gripper is equipped with cupping system, with a probing device for probing task. In the navigation task, the rover will use wheel speed sensors, an inertial navigation system and a specially developed vision system equipped with an NVIDIA Jetson module and 4 Full HD cameras to detect and recognize route markers. In this scientific project, we have focused on analyzing the geology of the Martian surface and looking for signs of life, extinct or alive. Knowledge in the field of geology and geochemistry will allow us to determine the evolution of the terrain, whether there was water or whether there is or has been life in biological concept. It is important because understanding whether life existed elsewhere in the universe beyond Earth is a fundamental question of humankind.